So, yeah, she did. She did. 3, what was it? 3, 5, 6, and 8. 3. All right, so remember, you always ask your question when you see these logarithmic equations. 1, is it log equals log, or is it log equals a number? What's this one? This one's log equals log. See it on both sides? So the first thing you're going to do is you're just going to say, drop the logs. They're gone. All we have to focus on are our arguments. So we've got x squared minus 5x equals 24. And that's how simple it can be if logs are on both sides. Drop them. Gone. Now, this one was a lot like C and D yesterday, where you need to bring everything on one side, and then, of course, go through the process of solving, and you got to do that by factoring. So we subtract 24, right? So x squared minus 5x minus 24 equals 0. So we're going to factor this like we did C and D yesterday into two binomials, right? So we go like this. What times what gives me x squared? X. So it's x times x. And then, of course, I see this sign. That's a negative. That tells me that one of them has to be positive and one of them has to be negative. So the signs are opposite each other. That way they're working against each other, right? And we're trying to find the two numbers that multiply to get 24, and they have a gap of 5. So did y'all come up with it?
3 and 8.
3 and 8. Now, if you're struggling with this ever, remember, you can just go to your calculator and you can start going 24 divided by 1. Well, that's 24. That's got a gap of 23. 24 divided by 2. That's 12. That's got a gap of 10. 24 divided by 3. That's 8. That's a gap of 5. Done. Okay? So 3 and 8 will do what I need to do. So my last step is this. What sign dominates?
Negative.
So negative has to go with my bigger number, my bigger factor. So negative has to go with 8, and positive has to go with 3. So I take those factors, and I set them equal to 0, and I solve. So for x plus 3, what do I do to solve that?
Minus.
I subtract it, so it's going to be negative 3. And with x minus 8, what do I do to solve?
Add.
So it's going to be a positive 8. And those are my two solutions. Now again, I told you this yesterday. To check extraneous solutions, you just plug them back in, right? And I told you that it doesn't happen very often. In fact, the only one that this happened with was number 8. And these work. And if you plug them back in, I know you'll see that, okay? So there's 3. Now let's go to 5. Again, number 5. Is it log equals log or log equals a number? It's log equals a number. So we're going to rewrite it as an exponent, right? So my first step is to recognize the base of my log. If it's not there, it's understood to be a 10. So we're going to write that as the base of my exponent, and then we're going to exponentiate. We're going to write it as an exponent. We're going to do the loop. So 10 to what power?
Second.
Equals what?
X squared plus 21x.
So that's what I'm left with. Of course, 10 squared is 100, and I need to move it over. So how would I move it over?
Minus 100.
So we have x squared plus 21x minus 100. So again, kind of like number 3, kind of like C and D on yesterday's notes, we're going to factor this into two binomials. So same process. What multiplies by itself to get x squared?
X.
What multiplies to get a negative? And a negative and a positive, right? So they're working against each other. So we're looking for what multiplies to get 100, has a gap of 21. Okay, that's a pretty big gap. Again, if you don't see it right off the bat, just go like this. What's 100 divided by 1? 100. That's a gap of 99. 100 divided by 2, that's 50. That's a gap of 48. 100 divided by 3 doesn't work. 100 divided by 4, 25. That's a gap of 21. There it is. Okay, it doesn't take that long if you have a calculator just to start dividing 100 by, start at 1 until you find the two numbers that give you what you need. And that's 25 and 4. 25 times 4 is 100. The difference between 25 and 4 is 21. So those are my numbers. So I look lastly at this and it tells me what dominates.
Positive.
So positive has to go with your bigger factor, and that is 25. 4 goes with the negative. So therefore, if I take x plus 25 and set it equal to 0, and if I take x minus 4 and set it equal to 0, these are the two solutions I get. Subtract 25, so negative 25. Add 4, so x equals positive 4. And again, I check these with my calculator, and they work, okay? They work. Questions about that? Anybody? Good? All right, then let's just go right across the page. It looks like I've already kind of forgot to erase that. If you look at this one, is it log equals log or log equals a number? It clearly has log on both sides, right? So what's my rule? Drop off the logs. So what's left on the left side? X minus 2 over x. What's left on the right side? 5. Now, a couple of good ways to solve this problem, okay? The way I like to do this one is, what is x minus 2? What's happening to x minus 2? It's being divided by x. So what could I do to move that? What's the opposite of dividing by x?
Multiplying.
So I just multiplied by x. It'll allow this side to cancel, and I'll be left with x minus 2 equals 5x. Y'all could have also done what I showed you yesterday, where you make 5 a fraction, 5 over 1, and then you cross multiply. You would have been left with the same value, x minus 2 equals 5x. Now, what do we need to get together? What do we need to get together? Our variables. Y'all aren't talking very much today, huh?
Variable.
We need to get our variables together. So I need to move the x by subtracting. So negative 2 will equal, what's 5x minus 1x?
4x.
Now what a lot of people do wrong with this problem is we kind of have this bad habit of always taking the bigger number and dividing it by the smaller one. And we end up with negative 2 as the answer because of that. But you got to remember, we're trying to solve for x, right? We're trying to solve for x. So to solve for x, I'm dividing by 4, right? To isolate it. So negative 2 divided by 4 is negative 1/2, or negative 0.5, whichever one you want to put. Okay? Negative 2 divided by 4, negative 0.5, negative 1/2. Questions about that one? And if you plug that back in, the negative 1/2, promise it works. All right? So, last one that we're going to look at is number 8. And even though I don't think this is the harder method of factoring, people struggle with it the most. So first of all, let me just show you, or ask you, is this log equals log, or log equals a number? So we're going to drop off the logs. Now that includes the base 2. It's like those are the same, so they just cancel out. So what am I left with on the left side?
2x squared.
And what am I left on the right side? Okay, so very, very similar to number 3 and 5 and C and D from yesterday's notes. Can I just solve for x? No. I gotta load up a side. So in this case, when I load up the side, I can subtract this 4x from what? I can subtract the 4x from what? Yeah, remember on 3 and 5, when I brought those values over, I couldn't subtract them from anything because they were constants. But this time I can subtract the 4x from the negative 14x because they're like terms, right? So here's what I'm left with. 2x squared equal, or minus 18x equals 0. All right, so yesterday I told you guys that on number 8 you're going to need to factor it, but I specifically put what kind of factoring? GCF. Because remember, I can't back this into two binomials. It's not a trinomial, and it's not a special binomial, okay? It's not difference of squares. So here, I've got to recognize that what can I pull out of both of those two terms? What number can I pull out of 2 and 18? What number can I divide evenly out of 2 and 18? 9 will come out of 2. 2. I can pull a 2 out. But also, what variable will come out of x squared and x? So I'm pulling out 2x. I'm dividing out the greatest common factor, 2x. All right, so in the first place, what's 2 divided by 2? 1. It's kind of like they cancel, right? What's x squared divided by x? So 2x squared divided by 2x becomes just x. Now go to the second term. What's negative 18 divided by 2? There's where your 9 came in, right, Deanna? And then what's going to happen to x divided by x? Cancels, gone. So when I pull 2x out, when I factor out that greatest common factor of 2x, it leaves me with x minus 9. Now, how many factors do I have up here that matter? Do they both matter? When does a factor not matter? When does it not help me solve? If it doesn't have a variable. Does this one have a variable? Does that factor have a variable? Absolutely. Does that factor have a variable? So they're both important. So I need to take both of them and set them equal to 0. Does that make sense, guys? What I'm saying? If that were just a 2 that we pulled out, it wouldn't matter because it doesn't have a variable. But this one does, so I have to pull it out. So what would I do to 2x equals 0 to solve it? Divide by 2. What's 0 divided by anything? 0. On the other side, what do I do to get rid of that 9? Add it. So x equals 9. So x equals 0 and x equals a 9. Now, if you go back and plug 0 into your logarithmic equation, your calculator will give you an error. And that is why 0 is extraneous. Okay? It was the one problem where when you plug it in, it's going to give you an error. Okay? So 0 here is extraneous. It doesn't happen often, but sometimes these values will be extraneous. All right? So there you have it. Pretty simple. Hopefully you guys were able to do the other 4. If not, finish them up, and you can turn this paper in when you are finished. Okay, so today we're going to be doing that one last thing that I've been kind of talking to you guys about. I've been preparing you for what we're doing right now. Here, Caleb. What, you got a lot of omelets today? Why? Why you got so many? What? Why you got so many, Aiden? Oh, wow.
It's okay. Yeah. I don't know.
Bart comes in after being sick today, being all sassy pants.
You were sick?
No, I have COVID. I would not be here right now if I had COVID. What do you mean?
Okay, anyways. People can still be normal sick, you know that? I mean, I think we live in a world now where it's like if you're sick, it's like automatically you. Okay, anyways. So here's what we have already done, okay? Let me show you. We've solved this problem right here by creating the bases to be the same. See, is this a logarithmic equation? What kind of equation is this? Y'all see log written anywhere? Not logarithmic, it's what? It's exponential. Look, it's got a variable in the exponent spot. It's exponential. So here's what we've talked about already. We said that I can solve this because I can change 25 to have the same base as 5, can't I?
Mm-hmm.
What can I change 25 to have the same base as a 5?
5 squared.
So I took this and I changed that 25 to 5 squared, and all of a sudden it was kind of like what we just did yesterday. If I have logs on both sides, what will we be able to do with the logs?
Drop them.
Drop them. Well, if I have the same base on both sides, what was I able to do with those bases?
Drop them.
Drop them. So we dropped these 5s off, and we took the remaining value, which was n plus 10, and we took that 2 and we set it equal. And then the process was easy, right? What do we do to get n alone?
Subtract 10.
So 2 minus 10 is?
8.
Okay, so that was a great way of solving exponential equations. But I told you, you can't always do that. So we have to have another way. Let me explain. Go down to number 3. Can you make 61 have the same base as 2? Let's try it. What's 2 times 2?
4.
Times 2?
8.
Times 2?
6. No.
16 times 2? 32 times 2? 64. What did I just do? I went right past 61. So can I make 61 have the same base as 2? So I can't solve this problem by creating the bases to be the same. So there's a second method that we need to know in order to solve exponential equations when I can't create the bases the same. The only problem is a lot of times after I show people this, they don't go back to the other method, okay? So here's the method. We're going to first make sure we isolate the exponential expression. Then I want you to mark this off. We are not going to take the log on both sides. We're going to rewrite as a logarithm. That's going to be our method. We're going to rewrite it as a logarithm. We're not going to need step 3 because we're using a better method than what they're trying to tell us to use, okay? Let me explain. Look down here at number 3. I've already proven to you guys we cannot solve this by creating the same base. But what can you always do with an exponent? Rewrite it as a logarithm. We can always rewrite an exponent as a logarithm. Watch. The base of your exponent, guys, what's the base of my exponent? 2 becomes the base of my log. Log base 2. And then we do the loop. Log base 2 of what? 61 equals what? So how can we solve for x? How can we solve for this value? We couldn't change the base, but how can I solve it now? I can go to my calculator, people, and I can type in alpha, window, number 5, right? Log base 2 of 81 or 61, right? So if I can't make the bases the same, does that mean I'm in trouble? No, it means I need to rewrite it as a what? A logarithm. And that's what we're doing today. Log base 2 of 61 equaled approximately 5.93. So 5.93 is x. Which should kind of make sense. Because remember when we were just multiplying? When did we jump past 61? 2 to the 6th power was 64. If 2 to the 6th power was 64, does it make sense that 2 to the 5.93 power was 61? It should. I mean, it's really close. It's the same thing. 5.93 and 6 are real close. 61 and 64 are real close. But here's the thing. Could you have ever tried to figure out that 2 to the 5.93 power would have given you 61? No, that's why we need to learn how to write it as logarithm. So we isolate our exponential expression, we rewrite it as a logarithm, and then always feel free to go back and check it. 2 to the 5.93 power will definitely be really, really close to 61. Okay? So let's go on over here to number 4. We're just going to look through a few of these. The first thing I'm going to encourage you guys to do is this. Locate your exponent. Where's my exponent here? M minus 7, and then its base is? Is it isolated? Is it isolated? Is there anything on the same side with it that is not a part of that exponential expression?
Yes.
What?
Minus 7.
No, minus 7 is up there in the exponent spot. So it's with the exponent. It's in the exponent spot. So there's nothing additional here. Okay, so we're ready to rewrite it as a logarithm. Here we go. Ready? The base of my exponent's what? That becomes the base of my log. Then we loop. Log base 8 of what? Equals what? So what's the first thing I need to do in my calculator? Log base 8 of 92. Alpha window number 5. Log base 8 of 92 equals what?
2.17.
So 2.17 equals m minus 7. How do I solve this problem from here?
Oh, add 7.
We're going to add 7. What's 2.17 plus 7?
9.17.
So m equals 9.17. Does this make sense? It's pretty easy, right? Mark out number 7. We're not going to do it anyways, but number 7 had a big flaw in it. I'm not sure what happened there. But anyways, go back to number 6. We're going to do it too. I just want you to mark out number 7 because it's messed up for some reason. Okay, here's what I want you guys to do first. What's your exponent? Number 6.
Oh,
3w. And what is its base?
4.
Okay, is that isolated?
No.
There is something this time that needs to move. What? Got to move that minus 5. How? We're going to add 5 to the other side. So 4 to the 3w will equal what? All right, now, do we have that exponential expression isolated? So we're ready to rewrite it as a logarithm. Y'all ready? What's the base of your exponent?
4.
So log base 4, and then we loop, right? Log base 4 of what?
3.
And what does that equal? 3w. All right, so go to your calculator. Alpha, window, number 5, base 4, argument 8, so log base 4 of 8 equals what?
1.5.
So 1.5 equals 3w. Now, how do we solve for w? Divide by 3. What's 1.5 divided by 3? So w equals 1/2 or 0.5. Either one is fine. How easy is that? Right? It's easy, right? Okay, let's do a couple more. Let's look at number 10. Number 10. Again, I want you to first find your exponent. What's your exponent here, guys?
P.
P. And what is its base?
5.
So that's what we've got to isolate. Does everybody understand that?
Yes.
So what are the things we need to move away from it?
7 and -2.
Got to move the -2, got to move the 7. Now, it doesn't matter which one I move first in math. Yes, it's absolutely important that we follow the correct order when solving. You've probably been taught this back when you were doing Algebra 1. It's like you're doing reverse PEMDAS, right? Like, for example, what's the closest thing to 5 to the p power, according to PEMDAS? What would you have to do first? You'd have to multiply, right? And then you would add, right? Because multiplication comes before addition. But when I solve, I've got to reverse order and do the opposite. So what I have to move first is the 7. You got to move the 7 first. And how do you do it? You subtract 7. So negative 2 times 5 to the p power equals, what's negative 63 minus 7? Negative 7. Now we move this multiplication by doing what?
Add 2.
No, not add it, because look, what is negative 2 doing to 5p? 5 to the p power. It's multiplying, right? So how do I tear it away?
Divide.
You divide by negative 2. You divide by negative 2. So what's negative 70 divided by negative 2? Negative 70 divided by negative 2. I'm sorry, negative 70 divided, yeah, I said it right. I don't know why. 35. Okay. Did I isolate my exponential expression? So we're ready to rewrite it as a logarithm. So here we go. Log. What's the base of my exponent? 5. So log base 5 of what? 35 equals what? So literally all I have to do is type this in and I've got my answer. Okay? So go to your calculator, alpha, window, number 5, log base 5 of 35. You're going to get a decimal answer probably, right?
2.2.
So approximately 2.2. As far as rounding goes, guys, I prefer you rounding to the 100th place, 2 decimals. But for example, in this one, if you rounded this one to the 100th, won't it round to 2.2? Just don't round to a whole number. Okay, that's the key. I don't want you rounding to whole numbers. That's always a bad habit. Okay? Alright, so that's number 10. Any questions with that one? Alright, I think we could probably get by with just doing one more, don't y'all think? So let's go to the hardest one on here, number 14. Again, first, identify your exponent and its base. What's your exponent? What's your exponent? 3 minus 7n, and what is its base?
8.
That's what we're trying to what?
Isolate.
Okay, so what do I need to move away from it first?
The time.
How do I move the 10?
Subtract down to 94.
So we got 3 times 8 to the 3 minus 7n power equals 94 minus 10, which is
84.
84. Am I isolated yet?
No.
No, I still got to get rid of that. What?
3.
Got to get rid of that 3. How?
Divided.
You divide by 3. So 8 to the 3 minus 7n power will equal, what's 84 divided by 3?
28.
Okay, now, do I have it isolated?
Yes.
So now we're ready to rewrite it as a what?
Log.
Logarithm. What's the base of my exponent here?
8.
So log base 8, and then do the loop. Log base 8 of what?
28.
And that equals what? That whole thing, 3 minus 7n. And that's what makes this problem a little more challenging, okay? The process wasn't just like the last problem. But the last problem, when we just did that, we had the answer. Here we got to do some more stuff. So go first to log base 8 of 28. What do you get?
1.6.
Yeah, 1.6. That sounds right. And that equals 3 minus 7n. Now again, you got to follow a specific order to solve for n. So what's the first thing you got to get rid of? The 3. How do you move the positive 3?
Subtract it.
Okay, so what's 1.6 minus 3? No.
Negative 1.
Negative
1.4.
So negative 1.4 equals, what comes down from the right side? Negative 7 times n, right? So lastly, how do I separate that negative 7 from the n?
Divided.
You divide by negative 7. What's negative 1.4 divided by negative 7?
0.2.
So 0.2 is my answer.
How did you get negative 1.4?
If you take 1.6 and subtract 3, 1.6 minus 3 is negative 1.4. Try it. 1.6 minus 3.
Yeah, I did.
Got it? Okay, so we know how to graph exponential equations or exponential functions. We know how to solve exponential equations in two separate ways, making the bases the same and rewriting it as a logarithm. We know how to graph logarithmic equations, functions. We also know how to solve logarithm equations in two different methods. Drop the logs, and if it's log equals a number, rewrite it as an exponent. They go together, they're connected, okay? So, hopefully you guys have a good beat on this. You understand what's going on. I'm gonna give you your homework now, and you probably have some time. You can probably almost finish the thing. So, your homework, and I'll tell you this again for you guys who don't have it yet. Your homework is numbers 2 through 16 even. 2 through 16 even on this worksheet. It's basically the right side of both front and back. 2 through 16 even. Also, real quickly, I have decided that this weekend, instead of doing a Google Form quiz, because it's hard to do a graph in a Google Form quiz, I'm going to, tomorrow, after we go through the review, I'm going to give you a take-home quiz. It's not ideal, but it's what we're going to do. I will be able to do that, but I was going to also just give you a hard copy.
Like, I think you take pictures and then send it like through the classroom.
Yeah.
Or you can just bring it Monday.